Now, the sine rule doesn't cover every possible situation. So we have a cosine rule, which helps us in those other situations where we have different pieces of information. So the cosine rule, to derive it, once again we'll drop in our perpendicular. It's basically Pythagoras' theorem. So using Pythagoras' theorem, I could say, well, h squared is b squared minus x squared, but I could say c squared is h squared plus a minus x squared. Simultaneous equations. So c squared would equal b squared minus x squared plus a squared minus 2ax plus x squared. Well, let's keep going with that. I then get b squared plus a squared minus 2ax. But of course, x is a pronumeral I introduced into the problem. So I still need to get rid of x. So in that right angled triangle, I can say, well, x over b is the cosine of c. And so that's how cos c gets into our formula. So c squared is b squared plus a squared minus 2ab cos c. As I say, basically it is Pythagoras' theorem. The only difference is the minus 2ab cos c. In Pythagoras' theorem, c, of course, would be 90 degrees. And the cosine of 90 is 0. And so that's why you get Pythagoras' theorem, c squared is b squared plus a squared. But of course, it could be a squared equals b squared plus c squared minus 2bc. It could be b squared equals a squared plus c squared minus 2ac. And of course, the one we derived as well. So basically, the side that we're finding, then it's the opposite angle that we need to know. All right, quick little example for this one. This one would be t squared equals f squared plus m squared minus 2fm cos t. So subbing into that one, okay, we want t. So t would be 8. Now, that's to the nearest whole number, of course. The biggest mistake people make with this one, forgetting the square root. Actually, remember, that's t squared equals, some people leave it, well, I guess it would have been 64, wouldn't it, the t squared. So remember, it's the square root of all that to find t. If we have to find the angle, again, some people like to remember a different formula, but of course you could still write down the actual formula. It's f that we want to find, so I'll write f squared, and I'll just rearrange it to make cos f the subject, which comes up with the formula that some people just memorise. Now, if you are going to memorise it, all you need to remember is on the top, it's minus the side opposite the angle. So the other ones then are plus, and on the bottom, it's 2 times the positive ones.
That's right.
So cos f, let's substitute in. Now, before I do anything else, is this angle acute or obtuse? Why? Because if it's negative, we'll get an obtuse. So there we go. We end up with 140 degrees 33. They're the sorts of things you want to look out for just to make sure. So if the calculator comes up, you hang on, whoa, that doesn't make sense. This should have been obtuse, or this should have been. All right, we look at this one, and sometimes people go, whoa, sine rule. Oh, I can't use it. I've only got one angle. How on earth am I going to find B? Cosine rule. Oh, can't use it because it's not the right side, but you can use it. You still use the cosine rule in this one. But what you do, even though B is the pronumeral that you want to find, the key is the angle. So when I write it down, I'm actually going to do a squared as b squared plus c squared. So I'm going to have 3 squared is b squared plus 7 squared minus 2b 7 cos. And I've got an equation in terms of b. So it is possible to go and find b. It's a quadratic. There it is. B squared minus 14b cos 25 plus 40. So, of course, you say to yourself, what multiplies together to give 40? What adds together to give minus 14 cos 25? Anyone? No? No, of course you don't do that. There's no way we're going to come up with those numbers. So we go straight to the quadratic formula. So negative b, which will be 14 cos 25, plus or minus b squared minus 4ac all over 2. Now, of course, plus or minus means we get 2 possibilities. 5.85, 6.85. It could be either. There's not enough information there to narrow it down. So, okay, I've got two possibilities for the length of our side there. All right. 4i, 4j. Enjoy.